Hey guys, so today I'm going to show you how to reduce a diagram like this. I'm going to show you all the different techniques. I find it much easier though to do it in an example than just like listing the ways you can do it, so you actually know how it is in practice. Okay, so let's have a look at our diagram here, and you can see that there's no real simple way to do it. Like, we can't do negative feedback here or positive feedback here, and there's no cascaded systems. And this is often the way, especially in like test questions. They will give you like a tricky first step, and once you get that, then everything sort of falls into place. So what we actually have to do here, or there's a couple ways to do things, but let's do this. We're going to move this node to here. Now that's like very well, but there's a couple of caveats to it, which is that, see, if we were going along normally this way, then up to the G4, then to the G2, when we move this to here, when we go along, we go to the G1, then the G2, then into the G4, and then this way. That's not good because it's not like the original path. So what we have to do instead is add a little something extra to our new path to make sure that the sequence is the same as the old one. So let's go ahead and move that node. So this is that moved node. Oh, G4. It goes down. This goes around. This goes to our G3. So we can't leave it like that because if you are going, say, in this path, we would have never encountered the G2. So since it does happen when we change the node, we have to add a little something here to make sure that when it comes along this way, that we still don't get a G2 in this sort of section here. So we add 1 over G2, so when it comes along, the G2s will cancel out. That's simple enough. So I'm just going to go ahead and write the rest of the system so we don't forget. G5 minus. R. Okay. So now that we've moved the node here, it's very simple. So what we can see is that these two here and these two here are cascaded. So all that means is that we can just times these two together and reduce it down again. So when we reduced it down, it's just G1, G2, G4 over G2, I'm just gonna not write the whole thing out again so we can work on our next two steps, which is these two. So as you can see here, now this is what we call a unity. Oh, don't forget, we have it indicated here as a negative. So it's a unity feedback loop. Because there's no other function here, it's just 1. And then this one here, because this is at a positive junction. So this is what we call a positive feedback loop. Okay, so I'll show you how to work these out. So let's just, yeah, we have room here. Go ahead, positive feedback loop. So the way that this works is that you have to, that these are, well, it's very simple. Just plus them together. So we have G4 over G2 plus G3. So let's simplify this so it's a bit easier to compute with later. So let's times it by G2 over G2 to get the bases the same. And then we can have, we'll have G4 plus G2, G3 over G2. Cool, so that's our we've now reduced this section here. Let's go ahead and work on the unity feedback loop. So a unity feedback loop is also very simple. If you just remember this pretty easy formula. So it's A over 1 plus A. And A is representative of this top function here. So for us, our A is equal to G1, G2. So now we can write our unity feedback loop as G1, G2 over 1 plus G1, G2. Okay, now that we have our two functions, let's go ahead and write out our whole new system again. So we have our summation there. Now our new unity feedback loop, 1 plus G1, G2. Then it goes straight on to our simplified positive feedback loop. Which is G4 plus G2, G3 over G2. Then we have our last little function that we had not touched yet. So make sure not to forget any of your steps when you're reducing sections at a time. Oh, G5. C of S, R of S. Okay. So that's very simple again. We can use our technique from here because as you can see, these two are cascaded. Let me write that. So all we have to do is times them together. Now this is where things just get a little bit mathematical. So let's do our cascaded section. G1, G2 over 1 plus G1, G2 times G4 plus G2, G3 over G2. So once we expand that all out, we can get G1, G2, G4 plus G1, G1, G2 squared, G3 over G1, and I'm just gonna skip a couple of steps, go to G1 plus G1, G2. I just took the G1 out after. So Sorry, this is G2, just took the G2 out after expanding them. So now we can see that we have G2 is common in the numerator, so we'll take that out again. G2, G1, G4, plus G1, G2, G3, over G2, 1 plus G1, G2. Cross that out, and we have our new function. Let's write that out again in our system diagram. So we have our R in our summation into our big new formula. G1, G4 plus G1, G2, G3 over 1 plus G1, G2. See this? G5 is negative. So now we can see it again. You might guess that we have to use our unity feedback loop. Oh, sorry. Well, it is like our unity feedback loop, except now that we have a function here, so it is just a negative feedback loop. So negative feedback loop. So our new negative feedback loop formula is, maybe we'll use it in terms of G, just so we don't get confused. G over 1 plus G times H. Our G is this big function here, and our H is our G5. So let's go write it out all in one equation. So our G is G1. Actually, let's take this G1 out just in case maybe we can cross it off later. G1, that's a G4 plus G2, G3 over 1 plus G1, G2, and that's just our G term here. So now we put our 1 plus, let's take our G5 as our H and just put it out in front so we don't get confused. Then we need to rewrite our G function. So G1, G4 plus G2, G3 over 1 plus G1, G2. Now this is where things get a little bit complicated in our reduction method. So what we're going to do is we're going to times this one by our denominator here, this one here. So 1 plus G1, G2. Now that we've done that, it's actually like this. We've made the denominators the same for this whole denominator. And then we can cancel out this, and this. So let's rewrite that so we don't get confused. G1, G4, G2, G3 over our newly times 1 plus G1, G2 plus G5, G1, G4 plus G2, G3. All right. So we could leave it like that if we wanted to, but let's just, nothing's really going to change a lot here because of this one. But let's just write it all out in an expanded form, just so maybe there is something we could do. So 1 plus G1, G2 plus G5, G1, G4 plus G5, G1, G2, G3. No, there's not really much you can do. You can take the G1 out and the G1 out here, but with that one there, we can't really do anything. Okay, so now all we have to do is just write out our last reduced form. So we have RS going into our new function. Let's just write it with the G1 out maybe. G4, G2, G3 over 1 plus G1, G2 plus G5, G4 plus G5, G2, G3. Okay, there we go. That is our reduced transfer function. From this all the way to here. There you go. I hope it was helpful. Hope you enjoyed this.